Hi all, good morning. This is Cindhamani from the Department of Artificial Intelligence and Data Science from the college Welltech Multitech, Dr. Rangarajan, Dr. Sakuntala Engineering College. I'm going to take a video lecture from the subject Computer Networks, and the source code of this subject is 23CS421, and this is for second year, fourth semester. And the topics I'm going to take on today is types of computer networks, topology, layer and protocol, OSI reference point. So, outcomes of this video session. On the completion of this session, the learners will be able to understand what is LAN, what is WAN, and knows various devices involved in LAN, WAN, MAN, know the new trends in computer networks, understand various network topologies such as bus, star, ring, tree, mesh, understand advantages of each topology, understanding layering in computer networks, understanding the benefits of layering, and know the introduction of OSI reference model and TCP/IP model. Let's go to the each and every topic we can see. So for the first topic we are going to see is types of computer networks. There are three types of computer networks. One is LAN. LAN means local area network, and second is MAN. MAN means metropolitan area network, and third one is WAN, wide area network. So first we are going to see what is local area network. Local area network is a computer that interconnects computer within limited areas such as residence, school, university. When it is a particular range. If it is the connection is in a particular range. For example, if you take a Wi-Fi will be in a particular range. If you go out of the range, we can. So if it is in a particular range, then it is a local area. In schools, libraries, if you take a college systems, college lab, it will be connected with a particular lab will be connected to the particular net. So like, this is the example for LAN devices or wired LAN and wireless LAN. Basically, wired LAN will be every wired LAN. If you see here, every wired LAN is connected by Ethernet wire. So this is the Ethernet and this is a switch, and the switch hub is connected to each and every system. And another one is wireless LAN. Wireless LAN example is Wi-Fi. The next topic we are going to see is MAN. MAN is Metropolitan Area Network. Already we have seen what is local area network. Now we are going to see MAN, Metropolitan Area Network. Metropolitan Area Network is interconnects computer with computer resources in geographic range. That is, for example, the size of city. If it is the device is connected in the size of city like Chennai, inside the Chennai, inside Delhi, like this. If it is geographic region of the size, they are giving the example that the geographic region size is like metropolitan area, city. Metropolitan means it's a city. So MAN means what is a computer network that interconnects computer with computer resources. So the MAN devices, what are the devices we will use here? Switch, hub, routers, and bridges. So, for example, if you see, this is the MAN. If you know this MAN means what? Metropolitan Area Network, and this MAN is connected with this LAN. LAN means what? Local Area Network. For example, if I'm running a supermarket in a city, okay, if you take a Reliance supermarket or any small supermarket, if you take for example, if in Chennai, I will have a branches in Perambur, Madavaram, like that. So when you take this land one is Perambur and this is Madavaram and this is Tambaram and this is Havadi, like this. If you take this this four lands is connected with this metropolitan area network. So if this four is run by same supermarket, so if this is useful for this is the example for the metropolitan area network, how it works. Mainly it uses it inside the city. So this each land we already know how the LAN works. So this each LAN have one hub, and the hub is connected with one computer. This is the model of the metropolitan area network. Next is WAN, Wide Area Network. Wide Area Network is a telecommunication network that extends over a large geographical area for the primary purpose of the computer. When it covers a large geography, what is difference in metropolitan and wide area network? Metropolitan is also a geographical region, but a particular size it will be connected. But what is wide area network? It is over a large geographical area, extends over a large and devices, end devices and intermediate devices. For example, if I'm having this two, you take this one router and this one router. So one router is connected to the New Delhi and another router is connected to Chennai. So you can see the range of where is New Delhi and where is Chennai. So these two large geographical area is connected by an WAN. So this is the example for the WAN. So you can see the man and the van. This is the man and the man is connected by this LAN. Each LAN have a system. So next we will going to see. So for example, you can take a internet. Internet also will be a large area. It will cover in large area geographical large geographical areas. So till now what we have seen, what is LAN, what is MAN and what is WAN. LAN is a local area network. What is and it will cover the particular schools, computer schools, libraries, everything. And the man is a metropolitan. It interconnects with an geographical area, particular extents of within a city. That WAN is a wide area network, so we can say it will cover the large geographical areas. So these are the types of computer networks. So the next topic we are going to see is network topology. First, what is topology? The arrangement of nodes of the computer. Topology means, see, is there is a 5 nodes are there. This 5 nodes, how we are going to connect these 5 nodes? If suppose I'm going to set up a lab in a college or school, so I'm going to keep the first 3 nodes in the first floor and the second 3 nodes in a second floor, and how this first floor 3 systems and the second this 2 nodes is connected. So this is the layout. This is the we are going to see how the arrangements are going to done. So this so only we are saying it's a network topology, arrangement of nodes of the computer network. Topology means layout. So physical topology and local topology. Physical topology is placement of various nodes where we are going to keep these nodes. And logical topology means deals with the data flow in the network, how this nodes is going to connect. For example, already I have seen if I am keeping this 3 nodes in the first floor and I am keeping this 2 nodes in the ground floor, how this first floor nodes is connected to the second floor nodes. That is the logical topology, how we are connecting and how we are passing the data we want. So this is a physical topology and logical topology. Network topology has various types: furnace, bus, mesh, and hybrid topology. First, we will see what is bus topology. Bus topology. So you can clearly see here. So this is the bus topology. So bus topology means all data transmitted between the nodes in the network is transmitted over the common transmission medium and is able to received by all nodes in the network simultaneously. So what they are saying, all data are transmitted. So any data transmitted this node A, this nodes in the network is over a transmission line, a single cable. The transmission medium here is a single cable. The single cable is the transmission medium is able to received by. So when we are sending a data from A, these all devices will receive the data. If the sender sends the data, these all devices will receive the data. But how it will know who is the sender and who is the receiver? So here what will be if A is sending the data through this transmission medium? What is the transmission medium here? The transmission medium is a single cable wire. So when A sends the data through this transmission medium, then the B will be received. But whatever the data we are sending is will received by all the nodes which all are connected to the single cable wire, but they will reject only who needs to receive the data will only receive, other nodes will reject the data. Next, a signal contains that the address of the intended receiving machine travels from source machine in both the direction to all machine connected to the bus until it finds the intended recipient. So you can see here this uh, how many nodes is there? 4, 5, 6, 7. So 7 nodes is connected to this single transmission media, and this is both the direction, like the sender will send the message is also in this same line, and the receiving message after receiving this acknowledgement, if he is giving also, it will be done by a same message, and rejecting also done in the. So this is the signal contain the address receiving machine from both the directions. So it having a both the direction, it will transmit the message. So bus topology is nothing but a data transmitted through the nodes in the common by using a common transmission medium. It's like a single cable. So this is single cable, and the connection is done by both the direction. So what are the advantages and disadvantages of the bus topology? Advantage, first we will see what are the advantages. Only one wire, so less expensive. So we have seen that there is only one wire was there, so it is a less expensive and suited for temporary network. If I for temporarily, if we are going to use it, then it is suitable for. Node failure does not affect others. If one node is failed also, to others will not be affected. Because why? Because it says both the direction. So disadvantages are not fault tolerance and non-redundancy. What is fault tolerance? If that single cable is gone, if the single cable is gone, then the whole the cable, if the cable got repaired, then it will the whole nodes will be waste. And the limited cable length, we can't connect the single wire for a large of the systems. And no security. So what is why the security was less here? Because if the we already seen that before, if A is sending a message, if A is sender and B is receiver, but the A sends the message will reach all the nodes which are connected to that single wire. So the message is not it's not securely and safely going and reach to the receiver. So it is no security was not there. So these are the disadvantages of the bus topologies. So what we are seeing, what is bus topology and advantages and disadvantages of the bus topology. So we are going to see next topology, that is ring topology. Already we have seen what is bus topology. Ring topology is also a bus topology in a closed loop. You can see this diagram. Once again, as you can see this diagram, ring topology is also like a bus topology in a closed loop. This is peer-to-peer LAN technology. What is peer-to-peer LAN technology? Peer-to-peer means this each and every node will act as a sender and receiver, and each and every node in this loop is very important. Like it's we already seen a bus topology. In that bus topology, you can see that sender A will be there, and the sender B will receiver will be one node, and the sender will be one node. Here, this each and every node will be sender, and also here it will act as a receiver. So this is a, we will say as peer-to-peer LAN technology. Two connections will be there, and one to each of it is neighbors. See, you can see here this one node is connected to this node and this other node. So it's only two connections. So each and every node has two connections, one to each of its neighbor node. These two neighbor nodes. See here. So neighbor, and this is a unidirection. It will flow only in this direction. So it is a unidirection. And sending and receiving takes place with the help of the tokens. So you can see this token. If this token, I'm going to give this token here. What will happen? This whoever is having the token will ready to send the data. So this node need to send the data to this node. It won't send directly. For example, this is the node, this node, this node has a token. Okay, if this nodes want to send the data to this node, it won't send directly to this node. It will go by if the token, this node is having the token, so this node, this will go like this, and then only it will reach here. It won't go directly from this node to this node. So the token will go, it will pass through, the message will pass through this all the node, and then it will reach the receiver. So this only it is an unidirectional. So now we are going to see the advantages and disadvantages of the ring topology. First, we will see what are the advantages of ring topology. Performance better than the bus topology. It's a performance whereas we will see is better than the bus topology, and cause bottleneck due to weak links and all nodes with equal access. So the nodes, each and every node, I already said each and every node is important in the ring topology. So only all nodes with equal access. Next, we will see what are the disadvantages. Disadvantages is it's a unidirectional, it's not a bidirectional. So if single point of failure will affect the, if for example, if you take if any this node is failed, then this whole loop is collapsed. So only they are saying single point of failure will affect the whole network. And if load is high, the performance will be low. We already know that ring topology will work by a tokens. So who is having the token will send and send the data. So when we are giving more load to this, like it's like continuously the load is giving, then the performance will be slow. So these are the next one is security, because why here also security will be lagging due to, because if this node wants to send the message to this node, and the message will be passed through like this only, this is in unidirectional, and the message will be passed through all this nodes and it will reach the destination. So the message whatever we are saying sending, it's not a security, so no security is there. These are the advantages and disadvantages of the ring topology. So till now what we have seen, what is bus topology and what is ring topology. And what is bus topology? Bus topology is connected by a single cable, and the ring topology is a closed loop. And what are the advantages and disadvantages of bus we have seen, and some advantages and disadvantages of the ring topology we have seen. So we are moving to next. Next is star topology. Star topology is nothing but every node connected to a central node called hub or switch. You can see this node is connected to this central, and this node is connected, and this node. So this 5 nodes is connected to the central node called hub or switch, and we can call this as a centralized management. All traffic must pass through the hub or switch. So this is a star topology. So till now, bus topology, what we have seen, bus topology is a single cable, ring topology is a closed loop, and the star topology is a centralized management, which is connected, central node connected by hub or switch, and the traffic must pass through the hub or switch. So we are going to see what are the advantages and disadvantages of the hub of the star topology. Easy to design and implement. It's very easy because we have this hub and the centralized administration. You know, we already see this is centralized. Scalable. What is scalable? If I need to extend, I have only here 5 nodes. If I need I'm going to extend my organization, so I need to connect more again a more 5 more systems. So scalable means if this one system, this file, if here I'm having one system, same here I'm going to connect a 10 computers or 10 nodes, then the performance will be same. How the one node works while connecting to hub, the same performance will be there if I connect to the 5 more. Like I can extend the nodes, we can say scalable means I can extend the nodes, or next in the notes, and the performance will be same as how it worked as a single. When I was connecting to a single computer, how the performance will be there, the same should be there when I was connecting the same place to 5 computers. So that is a scalable. So we can see what are the disadvantages of the star topology. Disadvantages here is single point of failure. affect the whole network. Here also single point, not this single point. If the hub single point is failed, then it will affect whole network. And bottlenecks due to overload. See, the here will be traffic will be there, so bottlenecks will be there, and increased cost due to switch. So when I was for 5 nodes, I need to connect a switch of big. So when I was extending my nodes, then the switch and hub of usage of switch and hub will be more, and the cost is due increase the cost, it will the cost will be more. So these are all the disadvantages of the star topology. So star topology is mainly central management, central administration, which is connected by each and every node connected to this central of hub or switch. Mesh topology. Mesh topology is each node is directly connected to every other nodes in the network. We can see here a node. We can see this node is connected to every other node. See, this connected to here, and this node is connected to here, and this node is connected here, and so each and every node is connected to every other nodes. It's a fault tolerance and reliable. It's a fault tolerance and reliable. Next, we are going to see what are the advantages and disadvantages of the mesh topology. The advantages here is in fault tolerance. Fault tolerance means if a system is connected, this node is connected to, suppose this node is connected to this node. If this node connection, this connection is failed, then I can see the alternate path to reach the receiver. So, for example, if you see, so this is the sender. Suppose this is the sender and this node is the receiver. So I am going to send a message from this node to this node, but the path is got some failure occurred. So this path is not working. So if it is not working, then I am going to choose an alternate path. So when you are choosing this alternate path, this is the fault tolerance. This is meaning for the fault tolerance. For example, you can take a real-time example. If you're going to college, from your home to college, a same path. Suppose some days the path we have a take diversions like that. Then we are going to take a another route. The same like that. If the sender is going to, so if a sender and receiver is connected to a path and the data is sending in the same way, suppose some troubleshoots is there, then it's going to choose the another path this way or this way or like this also you can choose. So there's a lot of alternate ways. So that is the fault tolerance meaning, the fault tolerance. Next is reliable. Reliable means it will be trusted. We can connect. So what are the disadvantages? Issuing with broadcasting messages and expensive. It is broadcasting the messages a little bit tough because it is mesh, right? When we are the system need to be connection like broadcasting was very tough. The next one is expensive and impractical for large networks. When it is going for large networks, it will be impractical. So mesh, when you mesh means is when it will be like mesh means what is the mesh? It will be full of mesh we know. So same name only mesh means. So mesh is full of expensive and impractical. When it is going for large network connection, it will be very trouble for us. So these are the disadvantages here. Okay, still now what we have seen, what is bus topology, what is ring topology, what is star topology, and what is mesh topology. What is bus topology? There will be a single transmission or single cable where the nodes are connected. And the second one, what we have seen, a ring topology. What is a ring topology? Ring topology is nothing but the same single transmission cable is connected in a closed loop. And the third one we have seen what is star topology, the citizen central administration. Here you can see the hub or switch is connected to the nodes, and the mesh topology is each and every node is connected to other nodes in the other nodes in the device. Okay, if suppose this bus, star, and mesh topology, all these three are in the in a one device, then what will be this topology? Do you have any guesses? What will be this topology? This is that we will call as an hybrid topology. When all the topology is connected, then it is called as an hybrid topology. Hybrid topology is nothing but if the bus star mesh or if the ring topology and bus topology is connected, then it is an hybrid topology. So here, identify the given topology and determine how many cables and ports are required to have. So here you can see this is what is this? This is the ring topology. If you identify a given topology, what is this topology? This is then a ring topology. How many cables and ports are required to such networks? So how many cables here? Here is 1, 2, 3, 4, 5, 6 cables. No, only one cable is required and ports. So how many ports? Each device has one sender and receiver. So one send and receiver. So each network has two. So we should find like that. Next is layering in computer networks. Layering means decomposing the problem into more manageable components. So decomposing means was if I'm having a large problem, then I need to I need to get into small problems, and I will solve each and every small problems and make it into a huge. So decomposing means that when it is a large problem, break down into a small problem. Layering means decomposing the problem into more manageable component. Advantages here is it provides more modular design. So we can lay small when we are breaking into small, it will have a design. So it provides a more modular design, easy to troubleshoot. Protocols. What are the protocols we here? It is a set of rules that governs the data. Whatever we are sending the message, there should be a protocols that should be have a set of rules. Protocols in each layer governs the activities of the data communication. When you are doing the data communication, there should be a set of rules, and each layer should have some ethics like that and the activities of the data communication. So there is layered architecture. Layered architecture is two types of architecture. One is OSI reference model, another one is TCP/IP model. What is OSI model? The OSI stands for Open System Interconnection. It is a model for understanding and designing a network architecture that is flexible, robust, interoperable. Developed by who developed this OSI model? It developed by International Standard for Organization. The OSI model is not a protocol. It's not like a protocol rules. It's only a guideline and hence it is referred to as OSI reference model. What is OSI stands for? OSI stands for Open System Interconnection, and it is a model for basically it's for understanding and designing the network architecture that is flexible, robust, and interoperable. Who has developed this? ISO, International Standard for Organization. The purpose of this OSI model is to facilitate communication between different systems without requiring changes to the logic of underlying hardware and software. The OSI model was never fully implemented. The OSI model is not fully implemented. So next is TCP/IP. We will see the introduction. What is TCP/IP? TCP/IP is Transmission Control Protocol, or otherwise IP means Internet Protocol. Mainly was developed prior to the OSI model. Before OSI model, first they developed TCP/IP. Therefore, the layers in the TCP/IP protocol does not exactly match those in the OSI. We will see in the how many layers TCP/IP have, how many layers OSI have. TCP/IP is a hierarchical protocol made up of interactive modules, each of which provides specific functionalities. So these are the layers in the OSI reference model. But there are 7 layers in the OSI reference model. How many layers in this OSI model? There are 7 layers in the OSI reference model. Application layer, presentation layer, session layer, transport layer, network data link layer, and physical layer. We can see what are each and every layer we will do. So how to remember this layer? So how we will do from please do not throw sausage pizza away. So here two P's will be there. One P, please P was physical. Every you should remember down layer is physical layer and the middle will be a presentation layer. So simply you can note it down, and this is like remember the layers. Please do not throw sausage pizza away. Now you can see how the 7 layers will work. So I'm going to send a message from device A to device B. So if I'm going to send any messages and the message is going to pass through this transmission medium, we can say this is transmission medium or a physical medium. Before the message is passing through this transmission medium, wait a minute, for example. Before this message passing through this transmission medium, the message is going to process all these layers. What are the layers here? There is application layer, presentation layer, session layer, transport, network, data link, and physical layer. So first the message is going to application layer. So application layer, for example, any application in the system, if we are going to send it like I'm going to say open a Google, this is also an application. So whatever the application, if you are opening here only it will be working. So then the message is in application, I'm going to send a message and it's passed to the presentation. The presentation layer will process the what the message was, and it will pass to the session. The session layer will be it's a main layer. It will break down the messages into a small, and it will send to the transport layer. Transport layer is main. It's a very important layer in the OSI. After that, this transport layer is given to the network layer, where we will use given IP addresses, where the source, where the message going to, where the source address, the destination address, everything we are going to give in the network. And after that it will give to data link layer, frames, and after that a physical layer. Physical layer will be changed the will after processing into physical layer, last physical layer, then this will process to this given to the transmission medium. And when it is going to give to the device B, the first layer here it is processing is a physical layer, and our second layer is a data link layer, and third layer is network layer, and fourth is transport, fifth is session, sixth is presentation, and seventh is application layer. So what we have seen here, when the message is processing in the sender device A, and it will process from application to physical 7 to 1. But when the message is going to for in the receiver side to device B, it's going to process from down physical to application layer. And again you need to note that you can see they have the intermediate node. Only these 3 layers will be visible for the intermediate node. Other this transport, session, presentation, application should be very security. So this messages cannot seen by an intermediate person. So this whatever the messages we are sending, this uh, 4 layers is not visible. Only these 3 layers will be visible. So what we have network device, source and destination address will be there, frames, and this what this physical address will do will change into bits. If it is a wired communication, it will change it to bits, zeros and ones. If it is a wireless communication, it will send the message as a signals. So these are the 7 layers of the OSI reference model, and you can know now you can know how the message is going to process through the 7 layers. So this is one of the brainstorming. Can you find which one is correct? So the order should not be changed. I already said. Can you tell me which one of this is correct? So please pass this and find which one is correct and comment the answer. So this one is the real-time applications in day-to-day life and industry. We'll say as a SDG codes here. So some of the questions I am going to wow the real time is examine the different network technologies and application that you are using during the COVID lockdown. In what way it supports you? So note down the networking technologies and applications you used, and exploring the network resources available at your home and at your college. Summarize the role of system administrator for both the cases. So try this real time applications in a home. So till now, what we have seen, we have, I think so, we understand what are the types of networks is there. What are the types of networks? Types of networks are LAN, WAN, MAN, and the I think so. Now you are aware of the topologies. So what are the topologies? Ring topologies, bus ring mesh, star hybrid topologies, and I think so. You know the introduction part of the OSI and TCP/IP. OSI, you all know what are the 7 layers: application, presentation, session, transport, network, data link, and physical layer. Okay, I think so. You can able to understand all these things by this session. Thank you. Thank you.